Next experiment is write a Verilog program to implement 801 multiplexer using case statement and if statement. So two programs you have to write 8 is to 1 MUX using case statement and if statement. So I'll go to the program now. Okay. So aim of the experiment is write a Verilog code to realize the operation of 8 is to 1 MUX using case and if statements, behavioral model using, and you have to verify the testing using test bench. So you can see the block diagram representation of MUX. So general block diagram is this. This is n is to 1. So the data inputs are this d0, d1, d2 up to dn minus 1. So there are n input means from d0 to dn minus 1 input will be there, and you can see the enable pin here, and select lines s0, s1, s2, sm minus 1 is actually select lines, and one output line will be there. So we can design a circuit such that the output can select any one of these input. So depending on the select lines, if all the select lines are 0, 0, 0, then Y will select the data D0. Similarly, if the select lines are 0, 0, 0, 1, then Y will select D1. Okay, if all are 1, 1, 1, 1, then Y will select Dn minus 1. If n is equal to 3, we have 2 power sorry, for n is equal to 8, for n is equal to 8, okay, that is we have here 8 inputs, i0, i1, i2, i3, i4, i5, i6, i7 are the inputs, and 8 is actually 2 power 3, 8 is actually 2 power 3, so 3 select lines are required. Okay, suppose it is 16 is to 1, 2 power 4, so 4 select lines are required. If it is 4 is to 1, then 2 power 2 is 4, so 2 select lines are required. Here it is 8, 8 to 1 means 2 power 3 is 8, so 3 select lines are required, and select lines also input, and I0 to I7 also input. So depending on the select lines, Y will select any one of this data. Okay, so a multiplexer or a MUX is defined as a combinational circuit that selects one of several data inputs. Y will select any one of data inputs and it forward is to the output. The input to the multiplexer, this I0 to I7, you can give either analog signal or digital signal. Another name for multiplexer is data selector. So the truth table for MUX 8 is to 1 is, so 8 inputs are there, Y should follow any one of input. So you have to concentrate on select line. Y should follow which input. So select lines you write a truth table 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So these are the 8 possibilities for 3 inputs. If select lines are 0, 0, 0, then Y should follow I of 0 path. Okay, this will select this path, or here Y will select I0 path. If select lines are 0, 0, 1, then Y should follow I of 1. Okay, in the output, when you are verifying the output, whenever you make data select lines are 0, 0, 0, then Y will follow I0. If you make I0 is equal to 0, Y becomes 0. If you make I0 is equal to 1, output becomes Y. You change any other keys here. If any other switches, if you change, it will not alter because select lines are made as 0, 0, 0. Y will follow any changes is there in the I0. Okay, any other changes in the other switches will not reflect. Okay, similarly, I will go to the last case. If it is 1, 1, 1, then output Y will follow, or output Y will select I of 7 and it will forward it to output. So the program for 8 into 1 MUX is we have inputs I, which is 7 down to 0, and 3 select lines are there. So input is 2 down to 0 and output is Y, which is not a bus, single output is single now Y, and you have to manually enter register here. Okay, So I'll open this file. So you have to type like this only. Always at I comma s begin case s. So three cases. I think s is 3 bits now. So 8 different combinations. You can write 3 dash b 000 or simply decimal 0 only. You can write 0 1 2 3 4 5 6 7 colon, like that you can write. Then no need to write any b dash d. If you want to write in bits, then you have to write all this. Otherwise simply write 0 1 2 3 4 5 6 7. If case is, if select lines are 0 0 0, y is equal to I of 0. If it is 1, y is equal to I of 1. If select lines are 0 1 0, y is equal to I of 2. So that means y will follow that particular line. So case is ended with end case. For this begin, end is there. For module, end module is there. So I'll open, already project is created. So I'll open it. It is there in my folder. So I think I already explained how to create a project, everything there only. Okay. So this is the file. You can see here. You can drag this. Okay, see here. I created a file here. Right click and add new source. Okay. Select Verilog module. Type 8:1 MUX. Okay. Click next. Okay. Click next. For example, I'll show you MUX 8:1. Click next. So here you select I. I is input. So select bus here. 7 down to 0. Then select line is also input. So S is select line. It is 2 down to 0. Then output Y. It is change this one to output. Okay. Then if you click next, so automatically it will create a file. So here I already have a file, so I am putting cancel here. But in your, when you are doing in your lab, you have to click next here. Okay. So here up to it will, here it will generate. So manually you have to type here register. Very important. Don't miss. You enter register here. Output Y will be there. Output register you have to enter here. And after that, always at I comma s, no semicolon here. Begin cases. So 8 different cases are 0 0 0. 3 dash b means binary 0 0 0. Okay, when select lines are 0 0 0, y is I of 0. If it is 0 0 1, y is I of 1. If it is 0 1 0, I is y of 2, like that. So I already told, no, instead of writing binary, directly you can write decimal. 5 means 3 dash b 101. 6 means 3 dash b 110. 7 means 3 dash b 111. So I wrote both decimal and binary representation, both I wrote. So end is, case should be ended here. Begin this end. Module, end module. Save this. So in order to check the simulation, click here. Okay. Check syntax. Okay. Sorry, this one, no. I wrote both files are there, that's why. Okay. Now no errors are there. So again, right click on this file. Okay. Right click on this file. Add new source. Select Verilog text fixture. Type MUX TV. Okay. MUX test bench. MUX test bench. If you click next, it will ask for source file, associate source file. You select mux81.c, 81.v. Click next. So if you click, you are going to get this file up to here. Up to here you are going to get I is equal to 0, s is equal to 0, you are going to get. Okay, I is equal to 0, 8 is equal to 0. So now in order to write test bench, change that I is equal to 0 to some 8 bit, some random 8 bit value you give, 8 dash B. B stands for binary value you are giving, 8 dash B. So I naught to I7, you give any random data. I am giving 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay. Any data you can give. There is no rule that you have to give this one only. Any 8 values are given. Now, initially select lines are 0, 0, 0. Because normally when you create any test bench, default it will give I is equal to 0, S is equal to 0. So select lines 0 means 3 dash B 0, 0, 0. All these select lines are 0, 0. Then what output you should get? Output you should follow when select lines are 0, 0, 0, y should get I of 0. So what is I of 0 here? I of 0 is this, I of 1 is this, I of 2 is this, I of 3 is this. So when select lines are 0, 0, 0, output you should get 1. After 100 nanosecond, we made S is equal to 1. S is equal to 1 means in binary 3 dash B001. So that also you can write, instead of S is equal to 1, you write 3 dash B001. So at for this time 100 nanosecond, output you should follow I of 1. So in the random data, I of 1 is 0. So for 100 nanosecond, it should come 0. After that, once the switch is changed, select line is changed to 2, again you should get 1 because Y is following I of 2. Next, when 3 is select line is 3, I of Y should follow I of 3. When select line is 4, it should follow I of 4, that is 1. Then 5 means 0 should come, 6 means 1 should come. When select lines are 7, when select lines are 111, 3 bit 111, Y should get I of 7. I of 7 is 0. So that you have to get output. Now our file is this one. I am selecting MUX1, first one, that is using case statement. This is using case statement. You can see here, this is MUX program using case statement. So I am running the for simulation you have to run MUX test bench file, not this one. If you run simulate the second file manually, you have to enter the values force constant. If you run the test bench file, no need to, because we already given the test bench values here. Test bench values are here, so you have to run this file. So you have to check whether the syntax error is there here or not. So I'm clicking this, check the syntax. Test bench syntax I'm checking. First time we checked the Verilog file. Now test bench file also have extension .v only. So no errors in the test bench file. So now double click on test bench file. This one only. Now simulate behavioral model. So you should get the output is very very important. How to check the output of MUX. If it gets hang, once again you have to rerun it. So now I'll explain. It's very very important. Please see. First case. Okay. When your select lines are 0, 0, 0. Okay. When select lines are 0, 0, 0. Y is the output. It should follow I of 0. I of 0, what is there? 1. So 1 is coming. Now switch is changed. Select line is changed to 0, 0, 1. When select line is changed to 0, 0, 1, Y should follow I of 1. I of 0 is 1. I of 0 is 0. I of 0 is 0. So 0 is coming here. Next select lines are made 0, 1, 0. So it should follow I of 2. I of 2 is 1. So 1 is coming. Next 0, 1, 1 means I of 3. I of 3 is 0. Next when it is 4, I of 4 is 1. Next I of 5 is 0. When select line is 1, 1, 0, it should follow I of 6. Y of 6 is 1. Y of 6 is 1. See the cursor. And last case, select lines are 1, 1, 1. Y should follow I of 7. Last one. I of 0. I of 0 to I of 7. I of 7 is what? 0. So here what you give, that is important. Here randomly I are given 0, 1, 0, 1, 0, 1. That's why it's coming here. from I naught, from I naught 1 0 1 0 1 0 1 0, and select lines are also increased in the same order 0 1 2 3 4 5 6 7. So you are getting 1 0 1 0 1 0 1 0. So this is how to check the output in this one. Now if I here last case 7 is there now, select line is 7 and output is coming 0. If I in the dip switches, when you verifying output in the dip switches, if you made interactive, so immediately you change this one to 1, so immediately this will change it to 1. Again if you change it to 0, it will change. So y will follow y of 7. Now you change any changes in these switches will not reflect, because when select lines are 1 1 1, y should only change according to your I of 7, no effect on these switches. Okay, so y is actually following this switch. Okay, if it is high it will come high, if it is low it is coming low. So this is a output using case statement. Now I'll show you how to do using case statement, because sorry, if statement. Same program you can write using if statement also. Right click here, right click, add new source, select Verilog module. Again write here MUX if. Okay, MUX 81 if if. Okay, then okay, next again you select write I. Okay, write I, select bus 7 down to 0. Okay, similarly S, S is also input. Okay, it is also bus, so 2 down to 0. Next write y, change this one to output. This is not a bus, it is a single bit, so click next and finish it. Okay, so here I already have a file, you can see here, so that's why I'm not clicking next, I am cancelling intentionally. But in your file you have to create new file, so that it will create up to here. This file will be automatically generated. Again, a very important thing, manually you have to enter reg here. Otherwise once you save it and check syntax, it will give error in all these lines, so you have to enter register here. So always at I comma s, okay, no semicolon here, very very important. So if s is equal to 0, if s is equal to, if select lines are 0 0 0, you can write s is equal to 0, or you can write s is equal to 3 dash b 0 0 0, 3 zeros. Either you can write decimal or binary, any one you can write. So here 3 lines I wrote, 4 lines I wrote decimal, 4 lines I wrote binary, so that you will aware of both. If s is equal to 0, y should follow I of 0. If s is equal to 1, y should follow I of 1. Else if s is equal to 2, y should follow I of 2. Else if s is equal to 3, y should follow I of 3. Else if s is equal to 4. Instead of 4, here I wrote intentionally 3 dash b 100. 100 means 4. You can simply write s is equal to 4. Or you can write 3 dash b stands for binary 100. By default it is decimal. Okay, so that's why here no need to write 1 dash d decimal, because decimal is the default number system, so no need to write 1 dash d. So in here it's a binary, so 100 means 3 bits are there, so 3 dash b 100. So if I if s is equal to 5, y follows y. If s is equal to 6, y is equal to 6. If else if s is equal to 7, y is equal to I of 7. For this begin, this is the end. For module, end module is there. So now check the save it, check the syntax of this file, original file. I added already tb file, test bench file. Okay, but you people first you have to check syntax of, it should be in simulation mux, check the behavioral syntax of if file, no errors. Right click once again, add new source. Okay, select Verilog text fixture, Verilog text fixture. Click associate file. You type muxif. Okay, muxif you select. Click next. So it will open this file. It will open test bench file associated with the MUX if file. Again, the same test bench you can use. Give I value some 8-bit initial value, any random 8-bit. Initially S is S is 0. Okay. Initially S is 0. After 100 nanosecond, S switch is made 001. After 100 nanosecond, switch is made 010. After 100 nanosecond, S is made with 011. After 100 nanosecond, S is made with 4. It is in decimal 4. I am telling now. In binary, it is 3-B100. 100. So similarly, after 100 nanosecond, S is 5. 100 nanosecond, S is equal to 6. 100 nanosecond, S is equal to 7. That is 3-B111. That is also maintained for 100 nanosecond. So if you run this, again you are going to get the same output what I showed there. Okay. So check the syntax of this test bench file. So no error. Run the simulation. So I already have this. Same output will come actually. So same thing it will come here also. Okay. This output only you will get. For both same output because I have given the same sequence here and which is also same thing. Okay, this is about you can see the another video how to verify the output of MUX. Thank you.